Hi guys, so this is section P4, section 4 of the prerequisites chapter, and it's all about polynomials, okay? And in this section, we're going to talk about three different things. In this video, we're going to talk about the first two objectives. We are going to describe and define key features of polynomials and add and subtract polynomials. Guys, remember, these videos are your notes. So your paper should look just like the screen, should look just like the examples that we have. And it's good practice for any of the homeworks we're going to do or a quiz that might be coming up. So make sure you guys are taking good notes. These videos are also more brief than our actual lessons are going to be because this chapter P is prerequisites. You guys are supposed to already know these things, and it's just supposed to be a review. That's why they're shorter. I don't go into as much detail because you're supposed to kind of already know these things. If you don't, that's no big deal. Feel free to shoot me a message on Schoology or email me, and I'd love to give you guys more practice or review this a little bit more. But I'm kind of just breezing through this slowly but kind of quickly because it's supposed to be a review. Okay, so that's just a sidebar. All right, let's talk about what the heck is even a polynomial. So let's review. Here's a definition if you want to copy it down. A polynomial is a single term or the sum of two or more terms containing variables and whole number positive exponents. Okay, now let's take a look at these 5 expressions at the bottom here and figure out, are they polynomials based on this definition? Okay, so let's take a look at this first one. 2x plus 5x cubed plus 4. So is it a single term? Not really. It's the sum, right? I'm adding 3 terms here. They all contain variables and they all contain whole number positive exponents. So this is a polynomial. Awesome. Remember, when we don't have an exponent on a variable, the exponent is a 1. Do you remember that? It's a secret 1 when there isn't an exponent. Let's take a look at this expression. 2x plus 5x to the negative 1. What do we think? Is it a polynomial? It is not. It's not a polynomial because of that negative exponent, right? I need to have positive exponents only. Here's another one. The absolute value of 3x minus 7. This definition said nothing about absolute values, right? I cannot have an absolute value bar when I'm working with polynomials. Here, how about this one? 8x cubed minus 2x squared plus 3 divided by x plus 1. Same thing. That definition of polynomial has nothing about division, right? I'm adding 2 or more terms together. Here I do have adding of terms, but then I have a division of terms. Not a polynomial. And then this last one, 8x to the 5th plus 3x minus 2. Is this a polynomial? This is a polynomial. You might be thinking about, well, what about that minus 2? Think about subtraction. This minus 2 can also be written as adding a negative 2, right? If we wrote this as adding a negative 2, we would just kind of rewrite it nicely with a subtraction. Okay, so that is how this is also a polynomial, because we can rewrite a minus 2 as adding a negative 2, which hits that sum of 2 or more terms. Maybe in your definition you want to add, like, it can also be subtraction difference, because that's true as well. Alright, so now let's talk about some key features of polynomials. Hopefully you've talked about standard form before. Standard form is when our terms are in order by their degree. So what is degree? Hopefully we've heard that word before, and we know that degree is another word for exponents. Okay, degree and exponents are the same thing. But when something's in standard form, those exponents need to be in descending order. They need to be from greatest to least, okay? So check out here, right, this expression. Negative 4x, when there isn't an exponent, there's a 1, plus 9 plus 2x cubed. Right now, those exponents, the degree, goes from least to greatest, right? So this is not in standard form. We want to rewrite it like this. I have 3 terms, and we want those exponents, the degree, to be in decreasing order. That's why I put the 2x cubed first, 3, minus 4x, because that's to the first power, plus 9. There's no variable with an exponent there, so that's why it's a constant at the end. So that's standard form of a polynomial. Leading coefficient. Basically, there's a definition for you there. But another way to think about leading coefficient is if we were in standard form, like this is in standard form, we are working with this, really only want to work with polynomials when they're written in standard form. So if they're not, first thing, write them in standard form. And then to identify the leading coefficient, it's really easy. It's the first number. Okay, leading, think about line leader. Coefficient, it's the number being multiplied to a variable. So 2 is my leading coefficient. Really important. It'll tell us a lot about the graph. And what about the degree of the polynomial? It's the greatest degree, the greatest exponent. So this is 3. Okay, again, that's going to tell us a lot about the graph. Those 2 are really important key features of polynomials. Okay, we want to be able to identify those. Now let's practice adding and subtracting polynomials. So here, how these questions are going to be written. It's going to say, given f of x equals negative 9x cubed plus 7x squared minus 5x plus 3, and g of x equals 13x cubed plus 2x squared minus 8x minus 6. Find, let's go like this, find f plus g of x. Now this might be new to us. What that's telling us to do is add. That's all. That is telling us that I need to take f of x and add it to g of x, okay? I'm going to add these 2 functions. So the first way I'm going to write it is like this. F plus g of x equals, and look, I just take f of x plus g of x. And all this comes down to, guys, is combining like terms. Do we need to make a note of that? Combining like terms. That's all this is. And I want you to check out how we are going to do this. Okay, so I'm going to write f plus g of x, and that's how we want to set this up, equals, we are going to start the process of combining like terms. Okay, and I'm going to do this with a little underlining and different colors. You can do it with the underlining as well if you don't have different colors. So the first one, we have negative 9x cubed plus 13x cubed. Like terms because they both have x cubed, and I just look at those coefficients. Negative 9 plus 13 gives me 4x cubed. Oh my goodness, ignore that phone ringing in the background. And now I'm going to do plus 7x squared, that positive 7x squared, plus the positive 2x squared. I'm just focusing on things with 2 underline bars now. 7x squared plus 2x squared gives me a positive 9x squared. Okay, let's take a look at the next like terms. I have a minus 5x. Remember, whatever sign is in front of the number comes with that number. Minus 8x. Okay, a negative 5 minus 8 is going to give me a negative 13x. And then our last is our constants, the plus 3 minus 6. 3 minus 6 gives me negative 3. And there it is, guys. Combine like terms, I just added 2 polynomials, added 2 functions together. All that might be new is that notation. Okay, it's not going to say, hey, add these 2 polynomials. It's going to be in that notation. F plus g of x tells you to add the 2 polynomials. Let's take a look at the subtraction. So notice now, again, it says f of x equals 7x cubed minus 8x squared plus 9x minus 6. And g of x is 2x cubed minus 6x squared minus 3x plus 9. And notice now it says find f minus g of x. And what that tells us to do, not that hard to think about, is subtract. I want to rewrite this as f of x minus g of x. So I take my f of x function right here minus my g of x function right here. There's only one different thing that we need to do first versus what happened when we were adding. I need to distribute this subtraction through the entire second polynomial. Remember, just like distributing, if there's something in front of a parentheses, it gets distributed to everything after it, okay? So we're going to start this, and it's going to say f minus g of x equals, this stays the same. Nothing happens with that first polynomial. 7x cubed minus 8x squared plus 9x minus 6. But now I need to take this negative and distribute it to all of these terms in the second polynomial. And basically, a negative makes everything the opposite. So right now, guys, that's a positive 2x cubed. It's going to become a negative 2x cubed. Okay, a negative 6x squared, a negative to a negative becomes a positive 6x squared. Again, negative to a negative 3x becomes a positive 3x. And a negative to a positive 9 becomes minus 9. So that's the only difference so far, or really at all, between adding and subtracting. Highlight that, star it. That's the first thing that we need to do. Distribute that subtraction through the second polynomial. And now this just becomes what we just did with the addition. Combine like terms, and we'll be done. So I'm going to have, again, I'll write f minus g of x, and I'm going to do that underline thing again. Find our like terms. Okay, x cubed here, x cubed here. 7x cubed minus 2x cubed is going to give me 5x cubed. What's next? Let's see. Negative 8x squared plus 6x squared gives me a negative 2x squared. Remember, the variable stays the same. It's just the coefficients that are changing, that are doing the operation. I have a positive 9x and a 3x plus 3x gives me a positive 12x. Remember, whatever sign is in front of the number, negative 6, comes with that number, minus 9. Negative 6 minus 9 gives me negative 15. And that's it, guys. That's all this is, combining like terms in order to add and subtract polynomials. And there's my final answer. Okay, good review hopefully here. You're going to practice some. Awesome job. Let me know if you have any questions.